We are doing S block elements, chemical properties we are doing of alkaline earth metals. This is very important for exam, and our exam date is finally come. Exam date is 29 December 2020. So first is chemical properties of alkaline earth metals. Physical properties are already done in the previous videos. So first property is reaction with oxygen. So when alkaline earth metals are react with oxygen, then there is formation of MO, which is monoxide, right? Now beryllium have tendency to form peroxides, otherwise all elements are from monoxide. This is very important point. Next is reaction with water. If alkaline earth metals reacted with water, then it forms metal hydroxides plus hydrogen gas. Most important thing here to remember is if we react beryllium metal with water, then we use steam water for beryllium. We use steam for beryllium, and for magnesium metal we use hot water, and for calcium, strontium and for calcium, strontium and barium we always use cold water for a reaction, right? Now next is reaction with hydrogen. Reaction with hydrogen. When alkaline earth metals reacted with hydrogen, then there is formation of hydrides. Now when alkaline earth metals reacts with nitrogen, there is formation of nitrates. Let's move to the next property, that is thermal stability. One thing you have to remember in previous properties, this is the basicity order. What is the basicity order in alkaline earth metal is? So this is the basicity order for alkaline earth metals. This is very important. You have to remember this for exam. Next is thermal stability. Thermal stability for group 1 and group 2 can be explained with the two types. First is monoatomic ion and second is polyatomic ion. One by one we will discuss about these. We are going to compare these monoatomic anion and polyatomic anion. Right. First of all, what are the monoatomic anion? For example, monoatomic anions are H negative, and for polyatomic ion like SO2 negative, OH negative, O2 2 negative, these are polyatomic anion, right? O2 2 negative, O2 2 negative. Okay, now we will discuss one by one. First of all, polyatomic anions. Small size. जो monatomic anion is small size. Next point is thermal stability. Thermal stability of monatomic anions decrease down the group. Next, decomposition. Decomposition is increase down the group. Next point is the temperature of decomposition is decrease down the group. Right. Now, for polyatomic anion has large size. If we talk about thermal stability is increase down the group. And if we talk about the decomposition decrease down the group. And the temperature of decomposition is increase down the group. This is very important. So the next chemical property of alkaline earth metal is reactivity towards water. When alkaline earth metal react with metal, it forms metal hydroxide. Okay, and reactivity towards water is increase down the group, and order for this is, so this is the order for reactivity towards water: beryllium less than magnesium less than calcium less than strontium less than barium. Next is reactivity towards hydrogen. In case of reactivity towards hydrogen, we already discussed that when alkaline earth metals react with hydrogen gas, they form metal hydrides, right? And their order is beryllium is greater than magnesium, then calcium, then strontium, then barium. Reactivity towards hydrogen follows this order from top to bottom. And in the case of reactivity towards water, OH negative is an ion, and in case of reactivity towards hydrogen, matlab when they form hydrides, H negative will be an ion. Next chemical property of alkaline earth metals is solubility order. Solubility order can be explained on the basis of two factors. First factor is lattice energy and second factor is hydration energy. About these two factors we are already discussed in previous video, and we are going to discuss it again. Lattice energy from top to bottom, let size increase. If size increase, then lattice energy decrease. If lattice energy decrease, then solubility increase. If solubility increase and lattice energy decrease, then we can say that lattice solubility is inversely proportional to lattice energy. So now we can write that solubility is inversely proportional to the lattice energy. Now let's move to the hydration energy. Hydration energy top to bottom hydration energy, top to bottom size increase. That's why hydration energy decrease. As hydration energy decrease, there will be solubility decrease. With the decrease in hydration energy, there is a decrease in solubility. Okay, so we can say that hydration energy is directly proportional to the solubility. He stands for hydration energy. Now, if lattice energy is greater than hydration energy, then we can say that uh, that compound is less soluble, right? If lattice energy is greater than hydration energy, then solubility will be less. If hydration energy is less than lattice energy, if hydration energy is less than lattice energy, then there is solubility more, right? This is very important. Note it down on your notes. Now we are going to compare the lattice energy and hydration energy of ions of group 1 and group 2. So for group 1 and group 2, in F negative, OH negative and O2 negative ions, lattice energy is greater than hydration energy, means lattice energy factor dominate over the factor of hydration energy. And if we talk about variation of top to bottom, then top to bottom solubility increase and top to bottom decrease in lattice energy, which is greater than hydration energy. If we talk about group 1 and group 2 anions, chlorine negative, bromine negative, iodine negative, SO4 2 negative, CO3 2 negative, these ions are large in size. These are large size anions and hydrogen energy dominate over the lattice energy, means hydration energy is less and lattice energy is greater in these anions. If we talk about trend, top to bottom solubility decrease and there is less decrease in hydrogen energy. Decrease in hydrogen energy is greater than decrease in lattice energy. Decrease in hydration energy is decrease in lattice energy. These are the most important factors. Note it down on your notebook. So this is all about the S block elements. Till now we are complete our chapter. In the next video we are going to do MCQs about the S block elements and also chemical periodicity.